Okay, so let's see. This also involves suvat, right? So now let's count up our suvat things. It is moving upward. That's our initial velocity. Stops, that's our final velocity. Distance of 2.80 meters, that's our displacement, right? So we have 1, 2, 3 things, right? And so we can actually suvat this first, then F equals ma, right? Okay, so let's suvat first. Okay, now before we do this, and we might mess up the acceleration, the direction of the acceleration, I think we can agree that if we're moving upward and we stop moving upward, that our acceleration is going to be negative. Let's hypothesize. Let's step back and think about that, right? If you stop moving upward, then you accelerate downward. Because if you accelerated upward, you'd go faster and faster upward, but you don't. You're stopping, so you accelerate down. Okay? So in this case, we have a positive velocity, but a negative acceleration. This is a deceleration, right? Okay, so let's figure out what it is. Okay, so our initial velocity is positive 5.30, right? We stop, so our final velocity is 0. And then I'm going to guess that our displacement is that we go up 2.80 meters, okay? That's also positive, right? I don't think you can move down while moving upward, right? That's pretty straightforward. We want a, so we'll use no t. So v squared is u squared plus 2as. 0 squared equals 5.3 squared plus 2 times a times 2.80. Okay, so let's see. 0 squared minus 5.3 squared divided by 2 divided by 2.80 equals a. So this is how a will become negative, right? Parenthesis 0 squared minus 5.3 squared, right parenthesis, divided by 2 divided by 2.8. And I get negative a is negative 5.01607. And it just keeps going there, right? I'm actually just going to keep that on my calculator. Maybe even store it in a memory location like A. Okay. Now we're going to use that for our F equals ma. So when we set up our F equals ma, we'll use that, right? Okay. So normally we're done, right? You know, on the first skills or the first assessment you took, right? We were done. We just calculated the acceleration. Aren't you proud of me? Okay. But now we expect so much more of you, you poor students. Wow. Okay, the screen just dimmed on me here. So for this F equals ma, right, what we're going to do is, let's see if I can get a little more brightness there. What we're going to do is we're going to, the lights in the room just shut off. Okay, we're going to draw a picture of this mass sitting here, right? So this is 1.60 kilograms, right? Okay, and the forces acting on it are the unknown force, the tension, right? And then the force of gravity is acting down on this thing, right? So we've got 1.6 times 9.81, right? And that is going to be 15.696, okay? So unknown forces are always positive, gravity is always negative, and now we're set. We can set up our F equals ma, right? So we've got force minus 15.696 equals 1.6. And now we got to figure out what's our acceleration, right? This is our acceleration right here. So we're just going to pull that guy over. Minus 5.01607. Okay. And now we're set. Now we can solve this, right? So the acceleration that we got here, we're going to put in here. Okay. And now this is where the lights are really helpful. All right, there we go. Just standing up made the lights turn on. Okay, so I'm going to go 1.6 times that answer that I just got, okay, plus 15.696, and I get 7.67 newtons. And that's positive 7.67 newtons. Okay, this means it's still an upward force. Now, the question is, when would you ever need a downward force? Whenever that acceleration is bigger than the acceleration of gravity, right, then you'll need a downward force for that. Okay. But this one's less than the acceleration of gravity, and so you still need an upward force to retard that acceleration so that it's not as big as the acceleration of gravity. I hope that helps.